Hi and welcome. My name is Adam Lindberg and I'm going to do the GRiSP stream today. And this time we're going to continue working on the Datagram logger. So some background for those of you who haven't been tuning in before. We have at Per's home, we have he has a solar heating system that heats up water on the roof and sends it down to a tank, stores it, and then you can use it for heating or warm water and such. So we have a GRiSP system. He made a GRiSP system that controls this. So basically when the temperature goes up on the roof, when the sun is shining, the system will start pumping down water into the tank. And once there is enough warm water in the tank, then the system turns on and so on, turns off. So to be able to get some insight into how this system is working, he has set up a InfluxDB server and a Grafana instance and pushing some events to this time series database with temperature measurements and basically making a dashboard. And to do this, he's done a Datagram logger plugin for the Erlang logger, new logger library in Erlang that comes with OTP, which basically sends these log events as UDP to InfluxDB, and then you can easily show it in Grafana, for example. So today I'm going to continue working on this Datagram logger plugin. And there are a bunch of issues on GitHub, like small fixes and features we want to add, and I'm going to take a look at those and see what I can do. So I've set up a test environment where I installed InfluxDB. I installed a tool called Chronometer, which is a GUI for InfluxDB. This is basically an alternative to Grafana. I could have used Grafana as well, but Chronometer kind of worked out of the box and you can make graphs with it as well, and it has some query help, so I thought I would try it out. So I've started those on my computer and I have cloned and made ready the Datagram logger library, and now we'll see if I can get this to work and then maybe make some small fixes or features and then commit this or make a pull request. So this is kind of today's goal, to improve the logger library. And in general, it's about making it more like official, like more configurable, because there is some hard-coded things and there are some types of events that are not handled very well. So we'll just see if we can improve this Datagram logger and make it more generic. And then we can use this in other projects in the future as well. And it's open source, so other people can also use it. For example, we want to add syslog support to it or other things like this. So enough talking, and let's get into some coding. If you have any questions or anything, just let me know. Send a message in the chat and I'll try to reply as soon as I can. So the Datagram logger, actually let's first go to GitHub. So this is the library. It's under the GRiSP organization. And it's a pretty small plugin right now. It's basically only this module with some supporting code around, and it's 150 lines of code, so it's not much, but it's already a skeleton, and it's quite a powerful logging UDP log center, and we have hooked it up to the Erlang logger library that comes with OTP, so this all works. And if we look at the issues, there are some help wanted ones and some other ones that Per has added. So I'm going to look at these and pick one of them and start working, or maybe work on a few of them. Depends on how much I can refactor at the same time and how much I should refactor at the same time. So one example is that the MFA, so when you log in Logger using the Logger macros, So I can show an example here. I made a small test module. So you have a header file that you include from kernel, and you can use these macros, and you can just log a string, or you can log formatted messages or some other tagged values and things like this. I'm also a bit new to this. I will look at the documentation while I'm doing this. But in essence, when you do use these log macro, it will actually compile into the log call the module, the file, the line where the log is come from, and so on. So if you have a logging plugin, you will get these meta tags basically to your log call, and you can then use them to log to a file, or there are default loggers like logging to file and to shell. And in this case, we actually want to send them off in the Datagram packet, in the UDP packet as well. So currently, I think the current state is that we don't format this and we just drop them. So it would be nice to actually get them into the database. So to show you a little bit what's working so far. So I have in the bottom corner here, I have a influx shell. So here we can see which databases, and I created just one database called Sol. There is also an internal one that shows up. I haven't looked at that so closely, but I think it shows some kind of influx metadata and other system-related things. So I created a database called Sol, and in influx you can use some kind of simple SQL language. So I'm selecting this database to be the main one. And I can type show measurements. So I have two measurements, one called temperature and one called sol. The temperature one is something I added because I was running a example query. Let's see, I can't find it here. Temp. This one. So this is just from the documentation. I wanted to see if it worked, so I just did this. So in InfluxDB, when you just run a line, basically insert temperature and then lots of tags, this will just get inserted into the database and show up as a new measurement. So if I would type something else here, like my measurement, this would be added implicitly as another measurement or a table, let's say, in this database. So I don't want to do this. And for now, we don't care about the temperature one. It's just an example one. But what I did also is log some stuff from Erlang, which shows up in another measurement called also sol. So we have a database called sol, and inside that we have a measurement called sol. So it's a bit redundant right now, but that's just because it's hard-coded in the logger library. And the way we get this done is that, so I call this example function, and let's actually first check what's in there. So select star from, and if I show what's in the temperature, you can see that this line is there, which is exactly this line that I put in before. So exactly those values. So if I then push something else, like change some values here and show it again, you can see that that showed up. And then we can look at what's in the sol table or in the sol measurement. And there's already some stuff in there. And this is stuff that I already played around with. So first I actually, let's see, I did this. So I just called logger to manually add these messages, and that worked. So this hello that you can see here, you can also see here, for example. And you can see also that logger already adds some default tags like the process ID, the log level, and for some reason the process ID is then duplicated. I think, oh no, that's the group leader. Group leader in Erlang is the process who kind of soaks up the default I/O from any process. So every process has a group leader. So when you print to shell or to standard out, the group leader is the one who decides where to actually pipe that data. So normally in Erlang, if you print to shell, it will show up in the shell. And that's because the group leader of the shell process that runs the interactive shell is also the one that prints it, and so on. So lots of details like this. And this is also logged. So that's why we see a different process ID here. But that's all. We see the group leader, we see level, and we see the message and the PID. And then what I did is I also used my small utility module, this one, test utils. And in this one, I actually just created a function that uses the macro and sends the string I give it. And I did this, and you can see that now it actually supplies the file info, and it supplies the line, which is 10. It's a little bit in the corner here. So we get some more metadata. Also, you see that there's a different group leader and a different process because I actually restarted my shell in between. So that's why we see a different group leader in this case. So it's a new VM instance, and then the process ID is a bit random. So the goal, let's say, if we want to tackle this one, this task, the goal is to figure out where the MFA ends up into the log metadata and somehow also ship it to in the UDP packet and then ship it to InfluxDB. So I'm going to assign this to myself and start working on it. And so background, how my system looks like. So I'm using Homebrew. That's how I installed InfluxDB and Chronometer. So if we do this, we can see that I have, Chronograph, it's called Chronograph. I started InfluxDB. Capacitor is some kind of event service or event system that they use, that Chronograph uses for alarms. So you can run it standalone, but Chronograph depends on it. And it's also from the Influx Foundation. So I've installed, that basically comes with Chronograph, and I started all of those. I did also install Grafana, but I'm not planning to use it since Chronograph I think is good enough, I hope. So let's see, but it's running in the background at least. And if you just do this, if you do brew install all of these services, Chronograph, Influx, and then you start them using brew services, you can already go to the Chronograph web UI, which looks like this. And from there you can add data sources. So there's like a wizard that starts when you go there the first time, and you can add a local database. So I hooked it up to my local Influx database. There's by default no passwords or usernames or anything, so I'm fine with this since I'm just testing. And then you can go and explore stuff, and from here you can, let's say we can go back to show databases, and you can actually get those. So it's kind of like a glorified shell with all these helper tools and a nice web UI and everything like this. Can I actually get back my old query? Not really. So it took a while for me to figure out how to show the measurements from the database from inside the table. So if I do this and then I go, so I did this show databases, and now I go and say, well, show measurements on database name. So let's do this, and my database name is Sol. So I do this, and we get those two that we saw in the shell. And next I was trying to figure out, okay, so how do I show some values from this? And in Influx, you basically use select to show values. I don't know if they have a getting started tutorial. Yeah, here. So here's where they insert some stuff, and then you do a select from, and you will get these. So this is what I did, this example call, like the temperature, and you select star from temperature, you'll get actually all the lines. So this was the first thing I tried here, select star from temperature. But this doesn't work because you need a database name, and I couldn't really figure out how to do this. So first, if you go back and say, let's see, show measurements on. So I thought maybe you can use select on, but that didn't really work. And it turns out that the right syntax is, if I go here and say, let's just select level. You get the predefined pretty huge query because it has lots of features, but the key part here is from. So I'm changing this back to star because I want to see everything and I don't care about the queries. I just want to see all the data in the table, and that actually works. And I'm not entirely sure where the autogen part comes from. So the thing is, I created this database via the web UI here. So if I do sol.sol, this doesn't work. But if I put autogen back in, it works. I don't have to do this in the shell, so I don't really know what that's about. I'm just accepting it for now, and since I see the same data, I'm happy. This is something to learn for another time. So already we can see the data that we have that we saw in the shell, and we see my first 3 manual calls to the log function, and then we see the macro call that I made from my test, which has these more information in it actually. And you can also see that InfluxDB by default already figures out that sol.line or that the line field is actually a number, and it formats it accordingly. And everything else here I think is just interpreted as strings. So my next goal is going to get the module function arguments in here. Because that means that if you use this Datagram logger adapter for the logger library in OTP and you log stuff, you could actually do queries like, so let's say you added around a couple of functions, you added a timer where you check how long did it take to call this function. You wrap all the functions in a timer. Then you could actually filter this table and show a graph on the average function call time for all of those functions that you added this to. Or you could filter on the module and function name, for example, to see average in a module or in a process and lots of cool stuff like this. So once we have those as columns or as tags in Influx, we can do neat things. So let's see if we can do this. Now, if we go back to the code base, so let's try it one more time just to see that we actually get something in here. So let's do an hello2. Nothing really visible here, but if I go here and check, I see now I now have this message. So my logging library is up and running, it works, and I can send packets from here. If I want to know how or what happens under the hood, we can go into the logger, the actual adapter, and there's 2 callbacks you have to implement to make logger happy. That's the adding handler callback and the log callback. That's the only 2 that's needed for basic stuff. And the add handler one gets a config and returns a config. And this config here comes from whatever logger figured out before you added the handler. So if you put logger config inside a sysconfig file for a release, for example, for your system, this will get read in and put into that variable, and then you get that to this callback. You can then modify or adapt this config, and once you've done that, this variable here is what will show up in every log call. So you can instantiate things and so on. And then you get the log event, and you get your config, and then you just do it. So what we do here is we do nothing when we add the handler. We just pass the config along. And in the case of getting a log, we just check that the socket is instantiated and the host and port is set, and then we're actually ready to send. And we go into this function and we pick apart the log message, all the tags and things like this, and we try to format it, and we send it on to InfluxDB using genUDP. So it's pretty simple actually. Takes a while to learn all these functions. I think Per struggled a bit with figuring out what comes in all these tags and values, and some stuff is not documented, like what comes in supervisor reports and things like this. So you have to kind of try it out and see what happens. One more thing to note is that InfluxDB uses kind of a line format. Let's see if I can find documentation about this. Line protocol. So that's how they accept data over UDP, among other things. There are other ways to pipe data to influx as well. And it's basically just a big string with the measurement name, a bunch of tag values, and a bunch of field values and keys, and then an optional timestamp. The original implementation, or this current implementation, is running on a GRiSP board, an embedded system in Paris home connected to these solar panels and these temperature sensors. However, when you start Erlang on the GRiSP board, you basically, you hook up a battery to the GRiSP board or plug it into the power outlet, and then you start Erlang, and there is no concept of current time yet. So what it does, it just starts with default Unix time, like somewhere in 1978 or 68 or whenever it is. So if you would start sending timestamps to influx based on the system time on the GRiSP board, you would get events like way back in beginning of Unix time, which is not what we want. So this is optional, which means if you don't send a timestamp, you actually get InfluxDB takes the timestamp when it receives the datagram and then uses that. So this is what we're using so far. So in our code, we don't do anything with timestamps yet. And this is another task we might tackle later, and that's that we want to actually use timestamps from the system if that's configured, otherwise just not send this. So this should be configurable if we send it or not. So in our case, we want to send the MFA. I'm not sure if we should send it as tags or as fields. I don't really know the difference yet, but I think if we look in the code, what Per's previously done, he sends it as tags. So that's, I think, what we should use, and maybe that's more like metadata that you can query on, and then fields is actually the value. So if we would want to send like a temperature, we would send it as a field, and then the module function argument would be tags, for example. So that kind of makes sense. So now back to where we were. Yeah, so we were sending things out here. That works. And they show up here. So the way to see how this works, we can actually use the Erlang debugger. So I'm going to start this here in my Erlang shell. Start a tracer. And I want to trace patterns on all processes. And I want to trace on function calls. And then I want to trace on, so we can start tracing by, for example, this log function here. So that would be dgram logger log, and I want to see return values and exceptions, and there's a shorthand for this x atom. So I do this, and if I make another log call, we now see the call to all module, and we see basically what shows up in there. So if we were to log something weird that we can't handle yet or get a crash in the logger, we would also see this here now with the debugger, which is nice. And we could also put a trace on actually gen udp send, and then we will see what shows up on the wire. So then we kind of know if our formatting is correct or something like this. And if we then send another log message, you can see that we send this log line here, and here we can confirm that we actually send this datagram format that InfluxDB wants. So sol is the measurement, and then everything is put in as tags, and then the only thing that actually is a field is the message. And then there is no timestamp either. So that's already omitted in our library for now. Yeah, that's the current state. So our goal is to figure out, basically, you can see already now in the log metadata, we get the MFA. And if we look at the meta tags, I think it's the format tag, and for the MFA, we actually just throw it away. So our task here is to format MFA as something sensible. So I'm going to take an initial stab at this, and I think it should at least for module and function. Let's see about arity, but we can probably just append them like this. So module equals blah blah function equals. So the MFA here is 3 tuple, and it would be the module function, and it's the arity. So we don't know which arguments the function would be called with, but since arguments can be huge, you don't want to log these things, so it's just the arity. So here we can do a list, and we can say, for example, module equals, and atom to list module, and we can insert already a comma because we know we're already also have a function, and we can do it here, and then atom to list again on the function. And for now, I think that's fine. And what happens with all these items, that basically this function gets called in a loop on all the metadata tags. So what happens once that's done, let's see, format tags is here. So we then join it with another comma. So we only need to insert commas, this one in this case, actually between the tags we generate inside this list. But if there is something coming after or before of some other type, there will be a comma added here already. So I think this should be enough already. Let's try it out. This Erlang shell here is started as a rebar shell. That means there is a, I think, undocumented shortcut where you can do R3 do, and you can call a normal rebar compile. So in the sense that I would do rebar3 compile here, I can also do it in the shell like this, and that will actually recompile and reload the modules for me. So that works. Oh yeah, so we forgot some stuff, and I should have seen this color highlighting. So we obviously need to add these items to the accumulator. This is the collection of all the tags. So we do this, and since we're not using arity at the moment, we're just going to ignore this. And we try again, no warnings. And now the Datagram logger module is already reloaded. So it's the new one, and I think if I just do this, it should already get the new stuff. Let's see. Oh yeah, so module and function and okay. So I'm not sure how that will show up in the. Okay, so it actually didn't even accept it, I think, because if you see here, there is no hello 6, and I think this message is like malformed according to InfluxDB, so it already dropped my buggy stuff here and threw it away. So that's good. The reason this happened is because this list, we add all the items separately. So what I wanted to do actually from the beginning was to make an IO list like this. And once the meta tags are done, it's formatted in here as a string, so that's okay. That means the outer loop would basically only add a comma here instead of between all of these items, which is what happened. So there's a comma after module equals, so it's a comma here, and there's a comma here, and so on. So I correct this. I'm not going to care about formatting now. I'm just going to get something that works, and then we'll prettify the code later. Let me try it again. And now it looks way better. So the module is there and the function is there. And if I select them, you can see there's already more data. And if we go here and confirm it in chronograph, we should see those columns, I hope. There we go. So function and module, and for the new messages, you can see them here already, which is pretty cool. I want to try also graphing like an actual number. I mean, I could graph the line number, but that's kind of a weird thing to graph. So I would rather, instead of this message that shows up here, I would rather log like a number. And I'm not sure how to do this yet, so I will just experiment a bit. And let's try to experiment using the logger module. So I can do notice. So if I do this, you can just send a string like this, I think. Yes, and that shows up here. And you can see there is a lot less tags because the macro is not used, so we don't get line number or anything. But what I want to experiment with is these tags or values. So kind of like, okay, so what kind of API do we want to have with this? How are you supposed to use this Datagram logger? And I think, for example, so this is a message. And then I think I can append tags like this. Let's just try it. Yeah, let's say temperature. I'm not sure if this works. Nope. So we need to go and read documentation. Actually, I think what should have worked is this, maybe. Okay, let's check logger documentation. So we're looking for logger log, or actually logger notice. That's the one we're using. String or report, and I'm kind of wondering what's a report. And it's this one, and it's a map or it's a tuple list. Okay, so I could send a tuple list directly. So that would be this. And now you can see, well, first our Datagram logger crashed, which means that logger for us is already removing the handler because it's a badly behaving handler. It couldn't handle the log formats, so it's removed, which means we need to add it back again. And I think currently the way it's added in our example code or in our test code here is it's just added in the gen server when the gen server start. So we should be able to do stop Datagram logger. It stopped, and then we can start it again. And I think now the handler should be back, and we can confirm this with get handler IDs. So Datagram logger is back. And now if I run this simple one, let's see if it actually pipes it out. Okay, so it sends something. Did it show up here? Yes, it did. And somehow we also formatted the data type, I think, because I'm guessing this I here means this is an integer actually. Let's check what shows up here. So if we now check this line, we can check. Okay, so temperature is here, the value is there. That's pretty cool. So we could already start graphing things, right? And there is obviously code in the logging library to figure out that this is an integer and send this correct tag. And if we check the line protocol, you have the data types, and then where do they actually talk about this? Okay, so here it's basically the I thing, and this is the line protocol reference still. So I'm kind of looking for just a table of what those codes could be. Well, seems to be like it kind of, okay, so an integer and a float is not the same. However, if I look at it in chronograph, it still shows up as a float, but maybe that's just a GUI thing. Let's assume that for now. I don't think it's super important. So that means in my example module, if I just add another function like temp value, so I can do log notice. Let's keep using notice for now. And I could here I could say, could have been a map as well, I think. Let's double check this in the documentation. Report, map, or prop list. That's nice. Let's use maps. It's more modern. So this is short. I can do this, and I want to export it. So now we have another nice function. Unfortunately, I was hoping, because I started the rebar shell, I started it with a test profile. So I was hoping that rebar would compile this test utils module, which I stored in the test folder, but it didn't do that, so I actually just did this for now. I just manually compile it into the test folder, and this works, so I'm fine with this. Test utils temperature, and let's log 6 this time. And now you can see we get the temperature equals 6, it's still an integer, and we get also all the nice flags and stuff. So if we go back to chronograph and refresh, we can see now we have a new one, and this is the new value. But we can see like the line number changed, and yeah, we log the module and the function. So that's pretty cool. And if, for example, now if I would want to do a dashboard, and I would have, let's say I would have 2 temperature sensors in my system, and they were maybe maybe they use different hardware. Like I have maybe a temperature connected via I2C protocol, and I have another none connected via SPI or something like this. Just different Erlang modules that would get data from these temperature sensors. I could then create a graph where, let's see if we can get something showing already. So I want to graph sol temperature. No, that's the other one. File function level. This is group by, so I could group by module, let's say, and I want to graph the temperature. So that means this is already cool. So this already works. You can see the temperature value I sent here. This was sent from the shell, and this was sent from my module. So if I go back to the shell and I send a few more values, let's do rand, rand, maybe, where is it? Rand uniform, I think. No, that's, there we go. Rand uniform. So let's log this, rand uniform up to, I don't know, 40 degrees. This time 21, and I add a few more values. If we go back to this one and we refresh, you can already see those values showing up here as purple. Now, if I go back and use my old call, and I also use rand uniform 40 here, let's actually use 20 maybe, because it's nicer. And you can see that it sends those values. And if I go here and refresh, I can already see the 2 different sources of temperature kind of for free, because I said group them by the module that logs them. In one case, the module value here is, I think, for the blue one, I guess it's null or something like this. And for the purple one, it will come from my test module. So if I had an Erlang system that did this, I could have 2 modules, one called like indoor temperature sensor and the other outdoor. And if those are 2 different Erlang modules, I could already create this graph and just split by the module that we get for free from Logger and already show usable data. So this is very cool. I think I will add also the arity, because why not? It's another pattern you can add, and you can maybe filter on this. So here you can say, show me only like the values logged from this particular module. So actually I can say if I am okay by grouping by this module, but I might want to use the arity, like only all the ones that come from the module and the function and the arity 5 or whatever, I can also do this. So let's add this. And we go back here and we also have in our formatting function, we have the arity. So let's use this. And let's format this. So let's do it maybe. Let's do it like this. Just to get some. And now we can also use this to add our arity. And now we can probably just put the arity directly in there because it's already, I need to format it, so this would be string something to integer. No, the other way around. To string. Where is this? That was in string modules. No, this is just the IO format. Sorry. So this is IO lib format, and I could use P, but and there is an integer one, which is I think B. Where is it? Writes an integer. What's the difference between capital but prints lowercase letters? Well, I don't really care about lowercase letters, so this is good enough. And this comma goes, and I'm missing a list thing here. So in Erlang you have IO lib, which does what IO format would do, like print to shell, but just return a string instead. So this is how I now format the arity into a string value. If I just would have put arity here, it would just have been an ASCII character, ASCII value, so that would be completely wrong. So I need to format it as an integer. Maybe there's already a integer format code somewhere here. Actually, we could use W, that's what we've used before. This would format the Erlang term, which also would work out of the box. But let's keep this here for now, and we can refactor later. So in the shell, I can now recompile. And unless I've done something wrong, I can just log another temperature value. And we should see the arity somewhere. Ah, there we go. And obviously I forgot the comma, so now I kind of broke the table a little bit, I think. Ah, okay, the function is just weird. So that's, or maybe it dropped the packet because there's two equal signs in one section. Probably it was dropped, yeah, because I don't see a new one here. So quickly fix the bug. And we do another logging. We check if it shows up, and it did. And now let's double check here if we can see the arity. So I guess it doesn't show up in this helper function yet because it needs to be refreshed somehow. I'm in a graph. Let's actually save this graph because I still want it. We go back to explore and we refresh this query, and we should see our latest addition, and we should see arity here as well. So now I could use that in my graph. I'm not really interested in this. The graph already works, so that's fine. So I think we're kind of ready to make a commit, at least because the basic feature is kind of working, and yeah, why not? So if we have an MFA and we just assume it's going to be this tuple, I think it's safe to assume, like, once Logger gives you a metadata tag with MFA in, we can assume it's this. And let's make the code crash otherwise here. So that's done. What's the current status? So I just changed the Datagram logger, and the only thing I did was actually add the format tag thing. So that's a pretty minimal thing. I think I'm going to just commit this. So test, actually let's add the test module also. So first, add simple test helper. So we could use this to write some unit tests maybe if I figure out how to do unit tests for Logger plugins. That's another topic, I think. Then let's commit this. Format MFA tags. So let's push it. So we're actually already done with this one. I should obviously have used the GitHub shortcut for fixing the message in here, but let's just make a note of the git SHA and say fixed in this one. And we can close and comment. So that's done. What next? So I think one of those would be nice because it means we dig into configuration a little bit. And when doing this, we have a chance to actually refactor some other stuff, some code smells. Actually, one of these are this one. So start the gen server from handler added instead of the other way around. So what does that mean? What we currently do or have, we have an application which has a application file and actually starts a supervisor, and the supervisor actually starts a gen server, and this gen server happens to be an instance of this Datagram logger gen server callback behavior, which also implements the logger callback. So, and in the init function of this gen server, we add this handler. So this is hard-coded right now. It's hard-coded to go to localhost and this default port of InfluxDB and so on. And it's kind of upside down in a way, because if you pull in this dependency, the dgram logger library, you probably don't want any gen servers started at all because you don't really need them. The only reason we have a gen server is so we can start the handler, and that should really be done by someone else. So what I'm going to do is I'm going to add some functions here to actually start the handler. So this is kind of our repository of test code that would actually be showing up in a real application that uses this plugin. So I'm just gonna do, I don't know, let's call it start maybe. And here I want to copy, so I want to copy this line and put it here. So I want to add a logger handler. Let's get rid of the sidebar again. So let's see, logger add handler. This needs a handler ID, a module, and a configuration. So the module we already set because this is our library that tests this module, so this is hard-coded, but maybe we want to supply the ID, and maybe you actually want to add several handlers, like pointing to different influx databases, or maybe some other syslog ones or whatever in the future. So let's ship the ID in here. And then we add the configuration. So I'm just going to re-indent it because I can't use the Emacs indentation since I don't have Emacs. So we add a configuration by default and we set a socket. And now it's a bit weird, like it's not where we add the handler where we should set the socket, right? So we need to figure out how to solve this. If we look at the old code, we open a socket and it's owned by this process, and the process owns this. So this gen server only has like two purposes. It's to start and open a socket and hold on to that socket so that all our other code can actually send and basically use this line of code here, right? And we somehow got hold of the socket reference. And the other thing it does is adds the handler. So we want to move out the handler adding because that should be done by an application that uses this plugin. But we don't want to supply the socket. So what I'm going to do here is I'm going to remove the socket because this test application has like no way of knowing like which socket to use or that it's responsible for starting its own socket. I think it's a bit weird. So let's not do that. Maybe it could be a future feature of the library that you bring your own UDP socket for whatever weird reasons, but I think for now let's just abstract it inside the logger plugin. So what we do here is we just ship the host and the port we want to talk to, and we export this start function like this. So now I could use that in my shell to like add the handler back. Let's maybe Let's add a stop function also. And I assume you need an ID at least to stop. And logger handler, so there is the remove handler ID. Okay, so let's just use this. Logger remove handler ID. Can it return an error? Yes, it can. So we're just gonna crash if it's an error because I don't know what to do with those yet. And we add our stop function. And to start, let's add also a config, so you can supply your own config. Actually, let's do both. So we have a default one. If you don't supply it, we'll just call start with ID and an empty config. And if you get the config, we actually want to merge it with this one. So we do maps merge, and we want this to be our default. This is our default map config, and we merge it with the config that you supplied. And that's it. And let's go one step further, and we actually move this out into a macro just to make it a bit more explicit. So like this. Since we merge in the supplied config after the default one, it means everything that shows up in here will overwrite whatever it's in the default. So if you just want to override the port, you can supply this. If you want to override everything or supply extra flags, they will all get merged in, and then this is the config that is used. Now, this config doesn't have a socket anymore. So if we go back here, and this line we should remove because the logger plugin itself shouldn't really add the handler. That's up to the user and their application. But this socket here is still somehow living. So what we need to do when you add, so the way it was backwards, as I explained before, was that the application started, created a gen server process, which then told logger to add our handler, and it gave the logger a config with the socket in it, and then passed it back into our library, which then had everything it needed. The reason this is backward is because the handler is supposed to be added by the user somewhere else. So now we can't add the handler here anymore, but we still have to be responsible for the socket. So it makes sense to have this process running. And when we now add the handler, we get this config in here, which contains our actual config. And what we want to do is we want to take all the stuff that's needed to open the socket. All the stuff. No, so what we want to do is when the handler is added, we want to add the socket here somehow and pass it on to logger, because logger takes this config that is passed in and may be modified, and it holds on to this config. And every time you get a log call to your handler, this config here that you get supplied every time is actually the config that you returned when the handler was added. So if we would print this config here, let's see, IO format, some ugly hack here. I'm not going to use logger itself because if we crash our own handler, it's going to get a little weird. So I'm just going to debug print some stuff. Actually, let's not do that. Let's just debug because that's the proper way to do it in Erlang. We're just going to check that we actually get this inner config because this is something we added ourselves. This is something we add here. So we should check for this here. This could maybe be called something else, but let's use that for now. And now if I compile this again, if I recompile this module, I can already stop and start a logger again with the new config. So let's try this first. So this would be my C call to compile the test utils. And now if I call, I should have start and stop in there. And now I actually should be able to call stop. And my old logger was called get handler IDs. Dgram logger, same as the module. So test util stop dgram logger, and so it's gone. And now I want to use my own custom start function, and I want to call it foobar, just so we see that the name works. That works. Now foobar is there. That's cool. Let's stop it again. So that code also works. And let's add a debug trace on the dgram logger add, was it add handler? Oops. Adding handler. So that would be adding handler. And I want to see the return value because I want to see later if we modify this config. Dgram logger adding handler. Oh, one D too many. Oops, come on. There we go. So you can see here the debugger says I didn't match any function names like this, so nothing, like no traces were added, and here actually matched one function name, one arity. And now if we add the foobar handler again, we can see a call to this function. And the config is, as we expected, it's the host and the port, but no socket. And some other stuff that logger adds, which is kind of cool. So maybe we can use this later for some stuff as well. This is what comes in here, actually. Oh no, that's a log event. Let's see. So if we would call the log function, we would have a problem because we expect this socket to be in there, which it isn't. So before we pass along the config, I want to maps put socket into C. So I want to take this configuration and I want to put the socket in there under this key and then pass it along. So how do I get this socket? Well, adding handler should start this process somehow, I think, because you want, for every handler, like if you create 2 handler instances and you point them to, let's say, 2 different InfluxDB servers, you want them to have each their own socket. They could actually reuse the same socket, the same UDP socket, because on a UDP socket you could send to anyone on any server or localhost or whatever from the same socket. So actually we could do this. So that means we only have to figure out in our supervisor. So this is the dgram logger gen server, and we call the start link function here, and we use a name. So that means that so let's assume for now that we force the application to be started, this dgram logger application, and that means that the supervisor has started, and it means that this gen server has started, and so this one, and we just need to ask this one for the socket. And so we do this, we do, actually we can do it down here. So we would get socket. And I think later maybe we want to move this to a different module just so the code separation is a bit cleaner. And we do a gen server call to this named gen server, which is called dgram logger. We can check this out actually by doing observer start. So this starts the Erlang observer GUI, which is pretty cool if you didn't know about this. Observer start in any shell that has a window manager and has this Erlang compiled with TX. And you can actually check all kinds of cool metadata about an Erlang system. You can look at load graphs. So this would be actually a cool thing to later send with the Datagram library to InfluxDB. so that's a future thing. But you can go in and check applications, and if we check the Datagram logger, we can see that the supervisor here is started. We have two other, one is the application process, and one is the, I don't remember what the other one is called. So this is the application master process, and this is, both of them, I think it's like a meta supervisor for the whole application kind of, and then the application process itself, and then the top level supervisor of the application. So if I would have a bunch of supervisors, they would all be under this master process. I think this is the master process, and this is the meta supervisor that you get. And then under our supervisor, we started a child, so you can see that here. So this shows the current application and shows the running processes. So this Datagram logger process here in this tree is actually already started and running. And we can look at it here as well in the processes table. This is all the processes in the whole VM. And you can see that it also shows up here, and that the PID is 426. And if I go here and check, you can also see that the PID is 426. So this is the socket owner process, right? And we need to ask this, since it has this name Datagram logger, it's the same name as the module, so we use that here, and we just do the get socket call to this one, and then we return the socket. And in our handle request, let's change this actually so that if the request is get socket, we do a reply with state.sock. So this is this state here, and then we keep looping with the same state. And let's change it also so that if we call it with anything else, we crash. I like to do this because if someone figures out, like gets the PID of this and sends some weird stuff, it's always nicer to crash first, and then you can see those errors and handle the bug. So silently discarding like unknown messages, I think it's not super nice, because you might have weird bugs in the long run where you think you're talking to the right Yen server and it doesn't reply immediately, and you have timeouts, and it can take ages to debug. So I like to crash early and often until I know what I need. So actually, let's do this also for cost. This is actually unknown call. This is the request, and now we don't want this anymore. And let's do it also for info. Info is like just any normal Erlang message, but since Yen server takes care of all the OTP stuff, there is no risk that we'll get any OTP things in there, so we can actually crash on this. All right, so we just need to ignore state, and I think we're done. So no one uses getSocket, but we have this Yen server started, and now we can use getSocket. So getSocket and socket equals, and now we have our socket, and now socket is put into this map. Can you do that with maps? I'm not sure. The map syntax is like half-baked in Erlang, so some stuff works with the syntax, and some stuff you have to use the map module. So if we do this, something like this, and then I pattern match out like I do in the header. Config equals C. Can I now do this? I can. That's cool. So let's use the map syntax for that instead. That's a bit cleaner. So C sock arrow socket. One more of those, and since this is such a short call, I can just put it directly in there, and we're done. So that means once we add the handler, we'll now get the socket, put it into the config, and give it back to logger. And once logger calls the log calls, we know we'll have a socket in there as well. So let's verify this. So let's stop our logger, recompile, and start our logger again. Now, since I had a debug trace on this, if you reload a module, the debugger kind of, let's say, call it loses the connection to that module. So if you unload or reload a module, all the trace patterns that you have put on that module will get removed. So we need to do the trace pattern again. Stop the logger and start the logger. And now we can see that the socket is back. So we basically refactored so that instead of starting the handler in this yen server and actually only allowing one hard-coded handler, an application, which is now my test module, can add a handler or several handlers with their own unique IDs, and that will just work. And they will all use currently the same socket owned by this master process here, which I think is fine for now, since you can use a UDP socket to send to any host from any address. UDP is kind of flexible like that. We don't need anything more for the moment. And let's actually try to log some more temperature values. So we use this function, temperature 17, so that shows up. Okay, so our library still works and the refactoring is good. And if we go back to chronograph and if we refresh, we should see the new, we see the new values here. Wait, do we? Oh yeah, okay, it seems to be blue because it's the only one. That's fine. I guess the colors are auto-generated. So that seems to work. Can you zoom in? Oh, you can. That's very cool. Nice. So are we done, I think, with this one? Start the gen server. Well, I mean, we did half of it, right? We still kept the single yen server for the whole library, but we no longer add the handler from inside that yen server. So we allowed different handlers to be added and share the same socket. In my opinion, this kind of fixes this bug, because what I don't know, and this is something I guess to read up about in Logger, is when you get this callback to add handler, can you start a process here? Can you link to the caller of this function like the Erlang kernel, and will that process stay alive? So what we could do, another step of refactoring would do in our application, we keep the supervisor, but we don't start the singleton socket owner process anymore, but we start a socket process for each log handler. Maybe it's nice, I don't really know why. Maybe it's needed if you want to set different socket options in the future. So I would consider this half refactored by now, or half solved by this implementation. So I'm still going to commit because it works, and like put a checkpoint here, and then we can see if we want to fix this or not. So what's happened here? We took config from just passing it long to getting the socket. We added a function to get the socket. We removed adding the handler, and we added a call, and we fixed some error stuff. So I think that can go. Maybe we make 2 separate commits about this. And then also we added some more helper functions. So that could actually be 3 separate commits. So let's see. Let's wait with this one. Let's first add only these parts. And I want to edit this one so that we change from only the always reply OK to any request to crash on unknown calls. So we do that, and we add also the crash on unknown casts, and we add crash on handle unknown infos, and then we're happy. So this is what we'll commit now. It's just this gen server change about crashing, so it's a nice single commit. So this is crash on unknown messages to gen server, or to the gram logger process, maybe it's better. So that's that. We could also split it up so that we make one commit about the new API functions in the test util. But I think it kind of belongs together. Like if we remove the adding of the handler here, we also want to give some utils to add the handler back here, and also moving the config. So let's do this both in one commit. So that would be this code to get the socket and not add the handler, and then the utils to actually add the handler. So that's good. Remove adding of handler in the gram logger process. So what does this mean? So to give some more explanation, handlers actually now have to be added by users outside of the application. All handlers will share the same UDP socket for now. And functions to add handlers were added to the test utility module. So now if someone looks at this commit later, they will get some more help about how to proceed if they were using the previous version and suddenly like the handler wouldn't be added by default and so on. So let's see. So I'm going to note down here. So we get this. Let's push first. And then we take the commit SHA. So now we get a nice explanation here. And we go back to the issue and say, so what did we do? I mean, we kind of did this. So handlers are no longer added as from this commit. Next steps. Can I edit this issue? I could. So let's do this and then edit. So I can make some to-dos here. Handlers should be added by users and not by the application. So we want to use the normal logging API. This is what we fixed. So this is done. I think this add and store the PID in the handler. Okay, so what we could consider is then, as I said, like we start a separate gen server process for each handler. Start and shutdown, because that has to be taken care of properly. Right now, the shutdown is managed by the gen server just hanging under our application. So if you stop our application, that gen server will disappear. It wouldn't remove the handlers from Logger though, so maybe this final version is actually the ultimate version. But let's just add this for now. So this is like a half refactoring. So in the ideal world, we would start the application, I guess. Have a supervisor, a simple one-for-one that just sits there with no children. And every time you add a handler, you would add another child to this supervisor, which would start its own gen server instance. And you would then have a separate socket for each handler. And then when you remove the handler, we should shut down that gen server. So first let's check in logger. And there's a remove handler. And I'm assuming this might actually call a callback in my module. So there is some documentation about handlers, logger handlers. Let's see if they list the callback somewhere. Now this is in kernel logging, maybe logger API. Handlers. Okay, that was a very handler callback functions. This is what we're looking for. So adding handler, I mean, there's stuff like changing config and things. So we might want to, like if someone might want, if we allow, let's say, setting socket options via config, when this callback is called, this one, we might have to tell the gen server to set socket options. So this could be useful in the future. But I want to see, yeah, so removing handler. So this is the callback we want. So let's add this. So, okay, so let's do one refactoring first. And that is, I think, to move the gen server out into its own module. So we save this in source and we call it like, yeah, let's call it Datagram logger proc, because I think we only have one process basically per handler, and yeah, this is an instance of this, so that's fine. .url, and let's do a module skeleton. I think I have a gen server. Do I? Thought I had a gen server. Ignore that. So instead of that, why did that not work? Export. Okay, that was weird. Let's open it proc again. There we go. Gen server skeleton. So now we need to move this setup code into init. And I think for now I'll just return the socket because it's all we ever have in this state, and we can add this record later if we need it. And we need to add the get socket callback. So we do that here. And still keep the error thing. So now this is our socket. Socket. Let's call it the same so we can search and replace maybe in the future. And we started with this, but this time I don't want to start this with a name. And the reason is we need a process started for each handler. And since the gen server names, the local ones can only be atoms, I don't want to convert like or use the atom names, but register them globally in the VM. So I'm just going to make an anonymous gen server. And that's it. So now we can remove this code, and we actually want to move these things also into the process. So this is the actual API. So the start, we don't need the start, I guess. Is it used? It's exported but not used, so yeah, let's remove it for now. I think start link is all we need, and we're going to use that one, and we need to export our get socket function also. Now the get socket function actually needs an argument because we need to know which gen server instance to call. So here we actually need a PID, and think we can get this from the supervisor. So when we add a handler with an ID, we could, I hope you can get the logger handler ID inside the config. We can tell the supervisor to start a child of this process with that ID, and then we can figure out which PID it has, because we need the PID here if we're going to call this module and get the socket out. So let's for now assume we can get the PID somehow. So we remove the socket from here, we don't need the state anymore, and actually these functions are also moved, and the gen server stuff is gone. We don't really have an API. Gen server behavior is used there, so that's nice, it's a little bit shorter. And these are just the logger callbacks, and now we need to do dgram logger proc get socket. And we need a PID here, so this is still our problem. Like, we now have, hopefully in the end we have some anonymous process running somewhere, still in a supervisor, but we need to get hold of a PID. And here we need to start this PID. So actually here we have a kind of a bonus, because if we do this logger supervisor, so let's call it start handler, well, let's call it add handler, because I like when there's a start link, it's kind of like start this process linked, and having other start underscore, like it's kind of similar, so I like call them like something else, like add or init or something. So let's call it add handler. Add handler process maybe, because the handler itself is here. This is the logger handler. So, or yeah, I mean it's a process for this handler, so that's okay. And this function doesn't exist yet, but if I add it later, I want it to return OK, PID, which means we now have the PID. We won't have the PID here, but we will have it here at least. So we could also add it to the logger config. Maybe that's actually smart to do. Let's think about that later. First, let's make sure we can actually create this. And I want to give it an ID. And I think in this config, I hope that there will be an ID showing up. And if we remember from when we did the tracing on the add handler, I hope that there is an ID there. Yeah, look, so this is the case. We get the ID. So we can now do this. And now we have an ID as well. This is the ID we would use here. When we do start this ID, we'll get passed into our small test function and added as the ID here, and we will get it from logger here, and we then pass it on to the supervisor, so the supervisor can start a child with that ID. And I think for now, let's change this to a simple 1-for-1. Intensity period 10 crashes. Let's keep this. I'm not sure if Per had something in mind when he added those flags. I think the default is like 1 crash in 5 seconds. So 1 crash in 5 seconds, that's, no, that's the wrong way about it. That's this. And the other one is 1 crash in every 6 seconds, so this is pretty much equal to the default flags, so I'm gonna take the liberty and remove those. So now we changed it from 1 crash, well, 10 crashes in 60 seconds, not the same as 1 crash in 5 seconds, because you can have 50 seconds and then 10 crashes and trigger it. And in the other version, you can have 1 crash in 6 seconds instead of 5, and it would always like restart. So it changes the characteristics. Actually, let's keep the default. So the reason is, like, if you crash this process 10 times in 1 minute, the whole application will die. And maybe if we later start using this process when we do log calls, maybe, I don't know if that's smart, but probably not. But maybe when you reconfigure, and if you do it too often, nah, I'm gonna change it to the default for now, because I can't see a reason for when we need something more tricky than this. So the options, simple one-for-one works like this, that instead of adding a bunch of predefined childs that are actually started when the supervisor starts, you add one child specification, which is kept as kind of a template, and then when you call supervisor start child, that template will be used. So that means we can keep this. I don't remember if you should use the ID. I think the ID should be in there. And let's see. So Igor asks me, they could be milliseconds. That's a good point, actually. So if we crash 10 times in 60 let's check. Supervisor. Non-intensity period. Where are they? Intensity and period, 2 integer values. If more than, so it's seconds, so it's actually minutes before. So I think in this case I'll just remove them. So it's a good question. It's not milliseconds, as usually, like often in Erlang, you use milliseconds everywhere, like for timers and stuff, but the supervisor uses seconds. So you can't have like a crash setting more granular than 1 second, let's say, which is interesting, but yeah. So we'll add this child, and I'm just going to reformat a little bit. And this will now be the proc. And I guess I'll just use proc here as well. And there's no arguments in here. We don't need any default things. Let's remove this. And we don't have any internal functions. But we want this new one. So we want this function that we're using here. Add handler proc. Yeah, that's actually if you thought it was milliseconds and you said like 5,000, yeah, that's 83 minutes, so that's more than 1.5 hours almost. So that's definitely a different characteristic, Igor. So add handler proc ID, and we want to use supervisor start child. And let's see what that one takes, start child. And it's also a bit special because we're using a simple one-for-one, so we need to double check this. So start child, supervisor reference and the child spec. The reference is going to be module. I don't really like this like server modules. I usually put module in here and less lines of code. Init, why is it? I am not finished here. And the child spec. And the child spec is, in this case, a list of terms because we're using simple one-for-one. So what happens is the child specification defined in init, which is this one, is used, and child spec must instead be an arbitrary list of terms. The child process is then started by appending the list of terms. So this is this list of terms here, like this, let's say foobar. It's appended to the existing start function argument, and that's this list here. So if I would have this, in the end, the supervisor would call, would add a child, and it would call Datagram logger proc start link foobar. Now it's appended, so it would call this function basically. I don't have anything to add here, so I'm going to use empty list. And here I don't have anything to add either yet, so I'm going to use empty list, which means that, well, actually it's start link, so it wouldn't be the lists plus, it would be an apply with the arguments in that list. So what we will call in the end is this function here. So we do this, and you can't have an ID actually. So Maybe we shouldn't supply it here because we can't really use it. We could pass it in as an argument, which means that we would call this, and that means that we would get an ID in here, and this process would know its own ID. But I don't think we need this, so let's not do it for now. And let's just do this, and we can refactor this later. So star child here will return star child ret, which is okay, comma child, and this is a PID, I think. So we don't pass ID in because we don't know what we'll use it for. I don't like to add things that I'm not using yet, so I prefer to keep it clean. So let's add this one, start, add handler proc. Now, let's make it also a little more compact. Now, if we call this function, we will add a process, get the PID here. We can ask that process as soon as it's started for its socket, put it into the config, and send it on to log. So what I'm going to do as well is I'm going to also store the PID here. We won't need it in this call, but let's say later we want to, yeah, we actually do need it. So in the whole point of doing this exercise in the first place, when we want to do the remove handler, then we need the PID, right? Because we need to stop that child. So let's just see if this all works. That means that this one should no longer start this process by default. And when we add the handler from our little test module here, we should actually start a unique process for each handler. So let's, oops, what did I do? Where did all the modules go? Okay, that's weird. I think I somehow maybe closed the other ones. Datagram logger, let's bring them back. And util this one, that's enough for now. So let's see if this works. So we stop the application. So we tear down everything. Let's check in Observer. So the application is gone. And now we recompile. Keep our fingers crossed. Format status is unused. Format status was used, I think, by the gen server, maybe. Git diff current file. So where was this used? Format status. I mean, it's here. There we go. It was exported. So it wasn't really used. That's fine. I removed the export, and let's remove this one also, because it just, yeah, maybe it's some old leftover code. Recompile. And let's check Observer, nothing here. And then we do application start Datagram logger. So it shows up, and no singleton process anymore. That's nice. Let's see if we can now add the handler. So this was Datagram logger test utils. So I didn't change any code here. This should just work out of the box. I just refactor the internals basically. And we do another start, and we do it with foobar. Boom! Already exists. Foobar already exists. So test utils. I know what happened. So I stopped our application, as we saw in Observer, but the logger handler was still there. So if I would have, before I started the application again, or actually already now as well, if I would make a log call now, that would crash, because that logger handler would have a handle to a socket that doesn't exist anymore because it was owned by the old process, which is dead. So let's try this. Where's my temperature? Yeah, so we get error closed, and I think also the logger should have removed the handler as well, because we had a crash. This is like the side effect I was hoping for. Actually not. Okay, so I can keep doing this and it's still there. Ah, return from. This is interesting. So this is a bug I found. Side effect. So as you can see, we don't match the return value of yen UDP send, which is normally okay, but it can obviously also be error reason. So because we didn't match this, I think logger just ignores the return value, so that handler would not crash if the socket would die. So this is a small bug fix also here, that we actually crash when we can't send messages, because there is no point in having a silent handler lying around that doesn't actually log anything. So let's fix this. R3 to compile. So my handler is still there, and now if I call this log call, I think it should crash, and now it says removed failing handler foobar. And this is cool with the new logging library, because my handler crashed, right, and it was removed, but the shell handler is still running and it prints my message, so this is very nice. So we've cleaned up a little bit in our runtime state. The handler is not there. My new application is already started and ready to go, and now if we start the handler again, should have worked, but it crashed. So let's see. Diagram logger sup add handler proc. Oh yeah, okay, so I said I wanted to remove the ID, but I forgot to actually not use it also, and we don't need it there anymore. So let's get back to the short version and recompile. Let's see, so the handler didn't work. My application is still up and running because Erlang is cool and it supervises everything, so I don't need to deal with this, and nothing was really destroyed. And I can actually, so I recompiled this just now, I can just do this again. Oops. And it should work. So let's check here. Now we have the anonymous process started, and it is still, so this is still, can you see? I basically want to check, yeah, so it's an instance of our dgram logger proc, so that's cool, and it's running. Does it have a socket? So the state, so this is the socket, it's also there, that's cool, and you could see the socket, this is this one, and now we are actually ready to log, and it should use the same configuration because we did this, right? So we actually should be able to log. Stuff was sent, temperature 26. Let's check, the last one was 17, so do we have anything new? Yes, we have 26, so our factoring is good, and we can log some more values, and we can go back to our cool dashboard, we can refresh it. I did zoom in, so I need to remove that. Oh, my window is a bit too date picker, past 5 minutes maybe. I want to see how I can get back to the current date. Okay, yeah. I didn't figure out in the UI how to switch back to this past 5 minutes thing, but now I have my new values in there. They work, so that's nice. So this is done. Now we have a process. So let's try actually start another handler. That should also work. What will happen though is that this handler will send the packets to the same influx, so you actually get duplicate packets. Now I'm going to test this separate config, and I'm going to say I'm going to use a different port, and the default port was 8089, so I'm just going to use 9001 here. And now if we ask logger get handler IDs. We have both of them. Let's see, can we ask logger for get handler config? Actually, you can also get all of them maybe. Yeah. Where is our handler? Our handler is somewhere in this list. So this would be this one. So since UDP is just like sending packets out, like there's no sessions or anything like in TCP. So if I would have said, for example, make a TCP connection to this host and this port, and if InfluxDB would listen on this socket, and if I would start a TCP socket connecting to a different port, which no one listened to, that connection wouldn't even be set up, and the open call to GenTCP would crash. But UDP doesn't have an endpoint. UDP doesn't have anything like a destination address. So every time you send a UDP packet, as you can see in our code, you have to send it to a host and a port. And the from address will be set to my host name or my IP number and the port I used when I opened the socket, which is this one. So this is a random port. And therefore, actually, both of these handlers will run, and they will both work, and they will both send UDP packets, but no one on the network, and in this case, my local host, will listen on this port, so this packet will just get dropped. So that means if I now run this again, this one, the temperature call here, I should see two calls to my logger library or to GenUDP, and one of them sends to 9001 and the other to 8089. And the 8089 one would show up here as the 32 call, but this one would just get lost in the ether because UDP. So that's a kind of primer on UDP. You can just send packets to anything from anything. Also, you can spoof your from address even, and they would just go out on the wire, and every router would just try to send them somewhere, and then if it doesn't know where to, or if it reaches a host and the kernel says, well, no one is listening on that socket, they would just get dropped. So we can now check that starting multiple handlers work. That's fine. We can have multiple handlers with different configs. If I were to add yet another handler with the same port, new ID. So that gets added, and we can see now that we have two of them points to the same port. They have a different ID. It's cooks and foobar. So now if I do another log call, we should get a duplicate entry here. Yeah, so we get 2, 3. Slightly different timestamps because timestamps still come from InfluxDB. But yeah, so we get duplicate data. This is my fault because I configured the system brokenly, right? I added 2 handlers pointing to the same database, which is a bug in my application, in my test here. But I just wanted to see that it actually works and that they can coexist. And they have different sockets, which is maybe good because if one socket or one process crashes, it doesn't affect the other handler either. So that's nice. So I'm kind of happy with this actually. This kind of works and it's pretty clean. We didn't add the remove handler. So if we now do this logger remove handler and we do it on, let's do it on the one that doesn't actually point to the database like this one. That would be, what was the name again? That would be Baz. And the process should, oh yeah, that's the thing. So the process doesn't disappear. The handler is gone. And if I log, I get my nice duplicate entries here still. But the process is still here. So we have kind of a memory leak, right? So we need to add the removing handler callback. Logger removing handler. So this one, it gets the config. And I think it gets the config that's set here. Not sure if you can update the config. No, you can't, because this return value here is just ignored. So you get the config that you set here. So that's this. And actually, I mean, we don't really care about the rest, but we do care about the PID. So we have our inner config and we have our PID. And now we can do dgram logger sup. Remove handler proc PID. And if we go here, no, the sup, where is the sup? There, the supervisor. So we can add our second called API function, remove handler proc PID supervisor terminate child, I think. Maybe time to take a break. Module and PID. Let's double check. Supervisor terminate child supref ID. And I think it can be a PID or a child ID. With the simple one-for-one, you don't get a child ID. So we just use the PID. It's an okay API, I think. It's not the best. What I would prefer is for the supervisor to know about all the handlers and their IDs and then map to the PIDs inside this module, self-contained. But since we're kind of keeping the state in the logger handlers config anyway, this is fine. And it's also cleaner because it's a simpler one-for-one supervisor, which isn't as advanced. And yeah, so I think it's okay. So we need to add this one, remove handler proc 1. So now we can use this API. And this one returns result, which can be either OK or error. So I'm just gonna pattern match on OK. And here I'm going to change so that we do OK PID and just return the PID. Because if you can't start this child process, I mean, there's nothing the handler code here can do, so there's no point in returning OK here. I think we can just return PID, and then we can crash internally in the supervisor, because if this happens, there is no way for the caller, in this case the handler, to recover in any way, so we just crash. That's fine. And this one we also crash if we can't terminate the child. It's less important, of course, but we want to see if we fail to terminate the child or if somehow this argument is wrong, so we need to check the return value here as well. Now, in the removing handler one, we can just get the PID and call this function, which would shut down this process, and in turn the socket that this process owns, this UDP socket here, UDP init, this socket would disappear as well. So that's actually all the cleanup we need to do. And we need to add this one here, removing handler, and it has the config as input. I like having the exports on a single line, because then you can do stuff like reordering them or deleting them easily without having to go into the list and like fiddle with the commas and stuff. It's a little bit more verbose, but I think it's more flexible, and I like reading it upside down instead of like variable length lists. So this is just how I like to do it. Okay, so we have the removing handler, and we already did remove one handler. The BAS one, so we can't test that, but we can test, for example, removing cooks. So we compile everything again. And now we should have all our remove code added, and we should have the new function in the supervisor to terminate the child. So let's try this. And so we keep an eye here on the supervisor, and then we call this, oops, not found. Oh, look at that, disappears, and it's gone. And if we now make a log call, we only get one socket event, and you only get one value back here. So that also works. Very, very nice. I'm super happy with this. So let's see. I think it's ready for committing, and let's see what we did. So we moved all the gen server stuff into a separate new module, which I need to add. Logger proc. So where is it? Doesn't show up in the div. Oh yeah, I need to add the other stuff as well. Cache. No. Add all of it and check the cache diff. So there's my new supervisor. Great. So we removed it from there. We changed so that the handler gets the, actually now also not only gets the socket, but creates the process, gets the socket, stores the socket and the PID. And when we remove the handler, we use the PID to shut down the socket owner again. We also fixed a tiny little bug. This might be a separate commit actually. When we send, and then we removed all the gen server stuff into this process module, and we also added to the supervisor all the management for the simple one-for-one stuff. So let's actually undo that and just commit this part. So this is about checking the return value. So this is crash on socket errors and sending. This is nice. And then everything else, I guess, can be added as one commit because it's all about moving the process out. So this is this, and start one process for each handler. Start and manage, because we also shut it down and so on. Supervisor was changed to simple one-for-one. We now start a separate process and socket for each handler, which is also stopped when removing the handler. Yeah, I mean the config can be separate per handler, but this was already true from before, so yeah, I think that's fine actually. We push those. Now I forgot to fix the issue with the commit message again, but since we've been keeping track with pasting the commits, I can do this time also. So this is this one, this commit, and this is the issue. So separate handler started for each, no, separate process and socket started for each handler added in this commit. And we can close that, and I can also check this little box here so it looks nice. So that's very cool. We fixed 2 issues today. I think I'm gonna call it a day. I need to go and have some dinner. And yeah, we made some nice improvements to the logger library. It still sends like these hard-coded events to like the sol table. So that would be something to do the next time actually. Make the actual log messages more configurable. So that would be fun. So yeah, thanks for watching. It was super nice to have you here. I hope you enjoyed it. If you have any feedback about our streams and such, just let us know on Twitter or on the Erlang or Elixir Slack. And yeah, have a nice evening. Bye.